In this online lecture, we are going to study about first law of thermodynamics. So, what does first law of thermodynamics has to say? Actually, first law of thermodynamics come under the branch of thermochemistry, which is a branch of chemical thermodynamics, and the science that deals with the relationship between heat, work, and other forms of energy in the context of chemical and physical processes. That is known as thermochemistry. So, first law of thermodynamics, if we talk about that, it comes under thermochemistry. And thermochemistry, as the name suggests, therm means heat, temperature, and it is related to in context with all the physical and chemical processes. Okay, let's say physical process, water liquid is converting to water gas. Okay, so let's say we are heating the water, it is going from the liquid state to the gaseous state. So what is happening? Physical process is happening, physical change is happening. It was liquid state of matter, here now it is the gaseous state, the formula is same. And now if it goes from, let's say, hydrogen and oxygen, it becomes water. So that is a chemical change. So what are the heat exchanges that are taking place? What is the heat change? Heat change is referred to as delta H. Delta H is enthalpy. We will talk about it. So what is the enthalpy change or heat change here involved in this chemical process or here in this physical process? So these kind of studies are done in thermochemistry. And here we are going to talk about the first law of thermodynamics also in a moment. And then moving on, we have, as we concentrate on thermochemistry, we need to consider some widely used concepts of thermodynamics. Substances act as reservoir of energy, meaning that energy can be added to them or removed from them. Now, if any of your system, let's say a reaction is taking place, or let's say your coffee inside a cup. Okay, let's say coffee is your system and everything around is your surrounding. Okay, so the systems, they are the reservoirs of energy. So coffee has energy, you have energy, and it means that energy can be added to them or you can take away or remove energy from them. Energy is stored in a substance when the kinetic energy of its atoms or molecule is raised. Now, let's say you start to heat it, okay, and then, so what do we understand by this? So let's say I start to heat this coffee here. Then what will happen? The energy of the system will be raised here. So essentially, what will happen? The atoms which are present here in the coffee cup, in the coffee, or the atoms of the coffee, they will gain energy and their kinetic energy will increase. So the heat energy will increase the kinetic energy of these atoms or molecules of coffee here. And when you're giving energy, so in heat, so kinetic energy is raised. So the greater kinetic energy may be in the form of increased translations. Translations mean straight line motion, so the atoms may start to move more rapidly in the space in the straight line. Or also vibrations can happen. Vibration means at its mean position it's just moving to and fro, and it can also, the atoms can rotate also. Okay, so this is how we say that kinetic energy is raised. Now when thermal energy is lost, now if the coffee cup here, it's just um it is just you just let it stay on the table in a cold weather outside. So what will happen? Gradually its temperature will decrease. So what will happen? The heat will flow from the coffee towards the surrounding, from the system towards the surrounding. So the instant intensity of the motions of the atoms, they will slow down gradually, right? So first they were moving rapidly, now what is happening, where it is losing heat, the system is losing heat. So what will happen? Intensities of these motions will decrease, and therefore the kinetic energy will also drop down. So this is about the energy give and take when you give energy. And then what do we want to understand here? The total energy of the system, the total of all possible kinds of the energies that are present in a substance, we call it as internal energy. Okay, so in chemistry under thermodynamics we use this term internal energy. I will write it here. Just give me a second, let me clear all these things and then let's write. We will talk about internal energy. So all the different possible types of possible kinds of energy that are present in the system. It can be kinetic energy, potential energy, okay, heat energy, any form of energy. So the total of all possible kinds of energy inside the system, that we refer to as internal energy. And what is its symbol? It's U. Okay, we write it in the form of U. Now moving on, as the system undergoes a change, its internal energy can change. Now, let's say our system is transforming. Let's say we were talking about water is become from going from liquid towards the gaseous state, or hydrogen and oxygen, they're combining to form water. So, as your system is undergoing a change, its internal energy can change. So, what will be impacted? You will be impacted, right? So, the internal energy, the total energy of the system will be impacted, and energy can be transferred from the system to the surrounding or from the surroundings to the system. So two of the things can happen. So from your system, let's say this is your system and everything else around it, it is surrounding. So these are your surroundings. So what we are saying, the energy you can flow from surroundings towards the system, or it can also happen, what is the other possibility, that it can go from system toward the surrounding. So these two options are available here. Energy is transferred into a system when it absorbs heat q from the surrounding. So what is happening here, when the u will increase, when energy is flowing from the surroundings towards the system, then what will happen, the u of the system will increase. So how the energy can flow in the system, in the form of q, when you start, let's say, heating it. So q is heat. So what is happening, when your system will absorb heat from outside, what will happen, the consequence will be u will increase, internal energy of the system will increase, right? So in that case we say u is positive. Okay, so when the system absorbs energy, u is positive. Or the second scenario is also possible, the system is losing heat. For example, you let your coffee cup outside on a good cold day outside, and then what will happen, the heat will flow from the system towards the surroundings. So what will be the impact, its internal energy will decrease. Okay, and also you can increase or decrease internal energy in the form of work. If you do work on the system, or if the work is done by the system, let's say your system is doing the work, okay, then what will happen, the internal energy will decrease. Okay, let's say you're doing gym, then your body is working out, so you're losing calories, you're losing your body is the system then, right? So internal energy will decrease. And then on the other hand, if work is done on the system, so internal energy will increase in that case. Now let's move on about the next bullet point. So for example, he's giving another example here. We have written one more for you. Energy is transferred into room temperature metal wire if it is immersed in hot water. So you take a metal wire, you immerse it in the hot water. So what will happen? The wire will absorb heat from the water. Or if you rapidly bend the wire back and forth, the wire becomes warmer. So if you take a wire and you just simply twist and turn it, you make it go bend back and forth, so the temperature will increase here. So this is one of the practical examples of looking into the internal energy. So let's clear all these drawings and move forward. Now the next thing what we are to say is both processes increase the internal energy. So what is happening here, both processes, they are increasing over here, they are leading to the increase of internal energy of the system, which is reflected by the wire's temperature. So if you go ahead and check it, the temperature of the wire will be increased. So conversely, energy is transferred out of a system when heat is lost from the system. So you can also think of an example where your system is giving heat to the surroundings, and in that case, internal energy will decrease. So let's move forward. And then what do we have next is uh, the relationship between internal energy, heat, and work can be represented by one equation. So we have been talking about work. If we do work on the system, if the system does the work, if heat flows from the system towards the surrounding, or from the surroundings towards the system. And then the next thing we are talking about the relationship with U, which is internal energy. So there is an equation that relates these three parameters: work, heat, and internal energy. Let's look into that equation. So that is uh, just 1 second. That is delta U. I will write it here. U is equal to Q plus W. Okay, so this is the equation that gives the relationship between internal energy, heat, and work. Okay, so this is the also known as first law of thermodynamics. Now let's talk about it in a bit more details here. Let's clear all the drawings, and then let's see what we have next here. And now we have a figure here. So as shown in this figure, this is one version of looking at the first law of thermodynamics. So, what does the first law of thermodynamics states? It states that uh, energy is just transferred in this universe. Okay, it is just transferred from one place to another place. Energy is neither created nor lost. Okay, so let's say someone puts money into your bank account, you gain some money. So you gain that money, the other one is losing that money. So the money just doesn't appear from nowhere. So similarly, energy doesn't appear from nowhere. Uh, the one system will lose energy, and so the other one will be gaining that. So this is so energy is just transferring from one place to another. So this is one version of the first law of thermodynamics, which is shown here, and it shows that the internal energy of the system changes through heat flow into or out of the system. So what is that? It's just the same thing which we did. Just 1 second. Let's clear first of all the drawings. Yeah. Now this is the system, these are the surroundings, and as you can see here, as the heat is flowing into the system, okay, then your internal energy will be positive, it will be greater than zero, so it will gain energy. And when heat is flowing out of the system, okay, or work is done by the system, then your internal energy will be negative, it will be less than zero, it will be losing internal energy, right? So W is positive if it is done on the system, and negative if it is done by the system. So you can see if the system is doing the work, then we will consider the sign convention that W is negative. If someone is doing work on the system, then W will be positive. This is the sign convention for the work. And this is just a caption that the internal energy U of a system can be changed by heat flow and work. So these two parameters can play with the internal energy. If heat flows into the system or work is done on the system, then it is positive. If it is otherwise, then it's negative. Okay. So this is what your first law of thermodynamics is all about, and see you in the next video.